Hello and good morning, everybody. I hope you are all doing well. Everything is fine. So we are still doing geometry and we are still dealing with circles. Today we are going to find all the relationships between some angles and arcs. So today's section is the fifth section from the 15th chapter that's titled Angle Relationships in Circles. Let's start from the first theorem. Okay. In two words, what does this theorem says, which is called intersecting chords angle theorem. I have two chords, AD and CD, that are intersecting at the point E. This theorem says if you have these two chords like this, then the measure of the angle 1 or the angle AEB, this red one, will be equal to half of the sum of the lengths of these two arcs. So the angle AEB equals to 1 over 2 times CD plus AB, which is here. That is the intersecting chords angle theorem. Now let's go and show how can we prove this theorem. So we will start from AD and BC that are intersecting at the point E, chords, and we want to arrive at this result. So we want to prove that the angle 1 is half of AB plus CD. Okay, so how can I prove this? I will start by drawing this segment that is BD. Okay, now after I draw BD, I'll say what is the measure of the angle 1? It is an exterior angle for this triangle. So it is equal to the angle D plus the angle B. Can you see this? Let me explain from another way. So I know that the sum of the angles inside this triangle is 180. So 180 minus E gives me B plus D. Okay. From the other way, I know that 1 plus E is a straight angle that is 180. Okay. Now 1 will be, of course, 180 minus E. And we know that 180 minus E is B plus D. So 1 is equal to B plus D. Okay, this is called exterior angle theorem. And I think you saw it on grade 6. Okay, now the second thing is I'm going to check this angle here, which is EDB. Okay, it's an inscribed angle and its intercepted arc is AB. What did we say from the inscribed angle theorem? We said that the measure of the inscribed angle is equal to half of the length of your arc. So EDB is equal to half of the length of AB. That is here. I do the same thing for the angle EBD. So here EBD is an inscribed angle and its intercepted arc is CD. The same theorem says that the measure of the angle B here, or EBD, is equal to half of the arc CD. Okay, now since EDB equals to half of AB and EBD equals half of CD, I will go and replace in this equation the measure of EDB. I will replace it by AB, and the measure of EBD I will replace it with the measure of the arc CD. Okay, now the measure of 1 equals to half of AB plus half of CD. Okay, I just replaced EDB by half of this and EBD with half of CD. Clear? Now just factorize half out, so you'll have the measure of the angle 1 equals half of the arc AB plus the arc CD. And that's what the proof is talking about. Okay, now let's check another theorem. It is called tangent to secant interior angle theorem. So basically, if I have a tangent that is BC, of course it's a tangent for my circle at point B, okay, and I have a secant that starts from point B and crosses the circle at point A, then this theorem says that your angle ABC will be half of the length of your arc AB. Let's take an example for this. So I need in this example to find the measure of the angle BCD, which is labeled here with this yellowish color. Okay, now I am given the length of this arc that is 142 degrees. So my theorem says the length of the arc, okay, multiplied by half will be equal to the measure of my angle. So I'm going to use this theorem here. So the angle BCD will be equal to half of the length of the arc BC. So it is half of 142, which is 71. For the arc ABC, okay, this arc ABC, I can use the same theorem. I would say the angle is ACD, which is 90 degrees, equal to half of the length of the arc ABC. So I will multiply both sides by 2. Then 90 multiplied by 2 is 180. So the length of this arc is 180. In fact, I can solve the same question here from another way. You remember that we said that the arc length equal to the measure of the central angle. Now, look at the angle A that passes from the center going to C. This is a straight angle, right? And it measures to 180 degrees. So this is a central angle, and it has the same length or the same measure as my arc, which is 180 degrees. That's another way. Okay? Now that's your turn. Here you have this circle. You have the length of the arc PQN, that is 238 degrees. And here you have the angle LPN measures to 61 degrees. I want you to find the length of the arc PN, which is this one, and the measure of the angle MNP. Pause the video here, solve the question. After you finish, play the video to see my answer. Alright, so I'm going to simplify the example by putting these beautiful colors for you. So what is PN? This is the blue one. Now I'm applying the theorem. So the length or the measure of the angle LPN, this one, will be equal to half of the arc PN. Okay, now I'm given that LPN is equal to 61. I will plug it into my equation. So 61 equals to half of the length of the arc PN. Multiply both sides by 2. 61 multiplied by 2 is 122. So the measure of the arc PN is equal to 122 degrees. Alright, now what about the angle MNP, the red one? Okay, so I'm going to apply the same theorem. I know that MNP will be equal to half of the length of the arc PQN, okay, or NQP, which is the same arc, okay. Now, NQP is 238, multiplied by half gives me 119 degrees. So the measure of my angle MNP is equal to 119 degrees. Alright guys, so let me finish up here. Tomorrow we are going to show other relationships and we will do more activities. Okay guys, take care of yourselves and see you tomorrow. Bye.